Okay, so step one before proceeding any further with our crazy new twist on a Peggle game is back up your working copy. There's no guarantee that any of these changes we're about to try are going to make our game better instead of worse. And if you go and change a whole bunch of files and then decide to go back to the previous version and you don't have a backup to go to, you're going to be hating life. So if you're not using some kind of source control, this might be a good time to take your files and copy them somewhere. I've done that. In my directory here, I just created a working backup folder and just copied all my files directly into here. So I'd recommend doing something like that if you haven't. So that being said, let's look at what we can do with our Peggle game. Or sorry, our Puggle game. So I'm kind of thinking maybe the first change I'm going to try is, let's see what happens if instead of making these pegs just light up when they've been hit, what if they suddenly become detached from our grid? So they actually start falling down into our world and, I don't know, I'm kind of making up stuff, but maybe we can, gain control of our chute at that time and use it to try and catch the pegs. And that will actually be how we score. No idea if that's going to be any good, but let's try it. So it seems like the first thing we want to do is if we want our peg to detach itself from the world and start falling when it gets hit, we probably need to go into our peg actor here, and in our hit by ball function, let's create another function called, let's call it turn normal. All right, so this will be a function that takes our current static object and turns it into an object with some real density. Now let's think about how we're going to do this. If we go back up to where we define our density, we don't do it within the body, we do it within our shape. All right, we've created our density in our shape definition that then gets created from the body. So if we want to change the density of this peg body, probably what we want to do is get into the shapes that make up this peg body, in this case it's a circle, and change the density there. Which brings us to an interesting question, which is how do we actually get the list of shapes that are associated with this body? Well, it turns out the answer is not quite as simple as you would first think. And let's turn to the PowerPoint to see why. Now, it turns out every B2 body has a function called getShapeList. And at first glance, this might seem like a very simple function. You call it, you get back an array that's got all the shapes in it. However, it doesn't return an array. I think maybe in the Flash world, if you're kind of used to using the words list and array interchangeably, the name of this function is a little deceptive. What it does return is a single shape. It just returns one shape in your body. However, that shape has its own function called getNext, which will point to the next shape in the body, and so on and so forth. So as an example, if I had a body that was, say, an arrow, it's made up of two shapes, the rectangle and the triangle up on top. If I were to call getShapeList on this arrow body, what I would get in return is, for example, the shape that makes up this rectangle. Now within this shape, I could call the getNext function, and that in turn would return the triangle that makes up the second shape of this body. And then if I were to call getNext on this triangle, it would return null, because there are no other shapes in this body. So this definitely seems kind of confusing if you're used to working with things in the Flash world. I would wager pretty good money that the reason it works this way is because, remember that Box2D comes from the C++ world, and over in the C and C++ world where they've got pointers everywhere, they really like using linked lists. And I think this whole concept came out of looking at the shapes that make up a body as a linked list. So if you're at all familiar with linked lists, you can kind of keep those in mind as you're working with these shapes, and maybe that'll make these functions make a little more sense. If you haven't used a linked list before, I guess just kind of think of this diagram, and hopefully that will clear things up for you. So let's go back to our code and look at our turnNormal function. So I guess the first thing we should do is iterate through all the shapes in our body. And using what we've now learned about our getShapeList and getNext functions, we can do that by calling this little for loop. So I'm going to call, I'm going to create a little variable called shape, which will be a B2 shape, and it will equal our body's getShapeList function. Or more specifically, it will equal the result of our body's getShapeList function, which will be the first shape among the list of shapes in our peg. Now we'll keep iterating through this list of shapes as long as shape doesn't equal null, and we can get our next shape by saying shape equals shape.getNext. This is kind of a common idiom that I use when I'm either iterating through shapes in a particular body, or if you want to iterate through bodies in your B2 world. So it looks a little strange at first, but once you've used it a couple of times, it'll sort of become one of those programming clips that you've learned from memory. So we'll do this, and within our shape, we can now set our density to equal 1. By the way, I've been informed that setting the density in this manner might not work in future versions of Box 2D. They're going to start taking these things, which are essentially just public variables, and force you to use functions that actually set the density. So if you're looking at this a year from now and this call doesn't seem to work, see if there's an equivalent function called something like setDensity. Now once we've iterated through all the shapes in our body, we can call our body's setMass from shapes function again, and this time we're going to get a much different mass for our body because it's now made up of shapes that are not static. And I suppose just to make sure that this thing starts moving, I can call my body's wakeUp function. This may be unnecessary, but I think it's kind of nice to have just in case. So let's run this and see what happens. Well, that's interesting. It looks like our pegs are still not moving, even though I'm pretty sure we went and we changed the density. Now, is the problem that our function isn't being called? Well, we can put in a little trace statement here, and I can assure you that it is being called. Yep, certainly looks like it's being called. So what would explain this behavior? I will let you ponder it over for a couple minutes, and then I'll give you the answer in the next lesson.